All right. Hello. Good morning, good afternoon, and good evening to all of you watching here today. My name is Andras Horvath. I will be the presenter of this titled Tracing Math's Post-Secondary Trajectories to Student-Teacher Race or Ethnicity. And a special shout out to Dr. Jacob Kirksey, our faculty member, Elijah Hand, and Jerod Jones for helping me make this presentation for you all. All right, so the problem that we were going to highlight in this whole presentation was going to be math disparities for race and ethnic minorities. The gap in demographic representation of students of color and their teachers has actually increased over the last couple of decades. So despite lots of work that's been trying to eliminate it, unfortunately, the growing student population is just growing too quickly for it to catch up. And this is incredibly important for example, math, which is a particularly important subject to consider when the growing body of research noting these racial disparities, talking about achievement, content coverage, or math identity, you can start seeing the problems here and why there's a lack of demographic representation in these fields by underrepresented minorities. And this is largely represented in a long-standing inquiries related to Algebra 1 being a key gatekeeping course. So especially for students of color. So what this means is that basically those students who are not able to complete Algebra 1 or do not have a positive outlook of it will end up just dropping off in math entirely. And so this is why Algebra 1 is just such a key course that my co-partner, Jerod Jones, is going to be presenting in his presentation shortly after this one. So do check out that. But there's lots of research that backs this up. Now, where this comes into play for us. So this specific presentation is going to be over the higher ed outcomes in future course taking. So we're specifically concerned about this demographic matching and whether or not these teachers are going to help influence their minority students on to college. And specifically, we were also curious, would they be interested in these math or STEM-based fields? So we do know that high school coursework has always aimed to improve student skills and knowledge before they go either to post-secondary school or whether they go straight into the workforce. And so having advanced classes such as AP, International Baccalaureate, honors classes, or as we also found, advanced math courses such as calculus, those more upper echelon courses in high school, we often end up seeing that this higher amount of academic challenge leads to more of an opening for these students that are of ethnic minorities, such as Black and Latinx, to get an idea of what college is all about and get a more positive outlook for these courses. And there's lots of research to back this up, as we have here, just mentioned by Grissom from 2020. He went ahead and cited two sources from 2006 and 2001 that showed some research that happened to show that these gatekeeping courses and whatnot were very instrumental in seeing how students would progress as they went on. And so what are policymakers doing about this? So a majority of states have active recruitment policies that are trying to target these underrepresented populations into teaching. I mean, Texas itself has over half its population is these underrepresented minorities we're going to be looking at here, being Latinx and Black. So a number of things have been attempted to be done. We also have policies such as Teach for America, the new Teacher Project Fellowship programs, and many, many more. And one thing that Texas itself has done is a teacher incentive allotment legislature. So trying to recruit or keep, for that matter, the most efficient and highly skilled teachers for them. But one thing that we are curious about is, would it be enough to just simply hire teachers that are good enough to teach math or STEM-based courses that are Black or Latinx, that would help these underrepresented minorities in these classes? And that's what we were most curious about. Would it just simply be enough to tip the tide, to push that needle just far enough that has a ripple effect long term that would end up helping these disparities in math or STEM-based fields way down in the future? Would this be enough to kind of change that? And that's what we are most curious about. So what do we know about demographic matching? There's a massive amount of work that has been done on this to show all of the wonderful benefits that it provides. For one thing, I mean, those teachers are more likely to be able to see better into their students' households, cultures, and schools. A lot of work has been done to see that there's better attendance rates, better academic success, and also lower discipline rates. And my mentor here, Dr. Jacob Kirksey has done a lot of work himself on this topic of attendance and absenteeism. But Gershenson, for example, here is one of the people highlighted here, did a study that specifically told teachers information ahead of time that was inaccurate about incoming students. And so what we would actually see is that those that were, for example, a Black teacher and a Black student, that versus a white teacher and Latinx student, I mean, something that's the same. We have demographic matching. What we end up seeing is that there was less bias towards that student and more of a push to help get them through and try to, encourage them, be a role model for them to pursue those classes to the utmost. And that was one body of research there that I wanted to quickly mention. Again, a lot of research has been done here. This is just a small list of the many, many works that have been done. So unfortunately, not all could make the cut for this particular slide. Egalite, Gershenson, Grissom here from 2020, do want to mention that was instrumental in kind of helping this presentation kind of get the ball rolling, because that particular study we wanted to basically recreate, because replication in social sciences has been a very appreciated movement recently. However, having better data with us having the entire state of Texas's data versus just Miami-Dade public high schools, or just district, I should say, excuse me, would allow us to have better quantitative analyses and better fixed effects and everything when it comes to this sort of stuff. So we want to take that, but then that particular piece didn't focus on post-secondary outcomes. And that's what kind of blossomed for this particular presentation. We were trying to see, is there something else we can go with this? And that's just something we were fascinated by, and that's where we are here. And then there's other work as well by Gottfried, Grissom, and Fletcher that's currently in press. And so this leads us to our research questions, which is namely, does having a same race or same ethnicity teacher impact students' probability of passing high school math courses for Black and Latinx students? Again, those are the two groups that we are specifically looking at, being the underrepresented minorities when it comes to math and STEM-based classes, and fields for that matter later on. And so from that comes our second question, being, does having a same race or same ethnicity teacher increase the probability, that Black or Latinx students will enroll as math or STEM majors in a 2 or 4 year college? And so we kind of broke the data down into two separate things. We had demographic data for the student and teacher, as well as transcript data. So when referring to the student and teacher demographic data, we are looking at a whole bunch of things, including gender, race, ethnicity, English learner status, also in some cases, immigrant status. But the key variables that we were taking away from this was going to be the race and ethnicity, and we were matching students and teachers by that. So for example, we have a Black student in Algebra 1 that is being taught by a Black teacher. This is what we're kind of looking for. And then we also have transcript data. So we are trying to link the teachers and the students via grade, so that we would be able to see whether the students passed or not, and then follow them through their trajectory through high school, and hopefully in our data set, even into college. And so moving on to the actual data here. So who's in our sample? Well, what we did is we went ahead and broke the incoming classes of 9th graders into cohorts. So for example, those that arrived in 2011 to 2012, that school year would be cohort 1. And we just went down the list, 2012 to 13, etc. And as we see here at the very bottom, we have the number of Black and Latinx students in the sample. This is a rough approximation. We have over 2 million in our starting sample, which is gigantic. And as we see that it does kind of drop off as we go along, which is bound to happen as students seek other things that come up in life. But by the very end, we have almost 800,000 as a rough approximation of the number that would go to at least 2 or 4 year colleges. So massive sample size. And then a quick mention about the analytical approach here. So what we did is we used 2 different OLS regression models that was supplemented with various levels of fixed effects. So quick typo in the first one, sorry, we were not able to change this ahead of time. In the first equation we had, it should be every Asian match, every Black match, etc. And so basically what we were just looking for is every single time there's a match between a Latinx student in geometry, for example, with their Latinx teacher, that being one match. And our second equation that we were looking at here was actually something that came up later. And thank you to Dr. Kirksey here for helping me with all this, incredible help with this. So the other thing was the number of matches. So are you being a Latinx student? Do you have a Latinx teacher when you take geometry, when you take Algebra 1, Algebra 2, etc., if you take calculus? I mean, in all these cases, we're trying to see the effects of the more demographic matches we have, what are those results? And so that's where the second OLS regression equation came from. And then moving on to table 2, we were looking here at the impact of having the same race or same ethnicity teacher in high school math courses and post-secondary outcomes. So we see here in the first column our outcomes and our key variables being Asian match, Black match, Latin, X match, and as well as white match. So again, are you a Black student in a calculus class with a Black teacher? That's what we're looking at. And the two most important ones here being the Black and the Latinx matches. Our Asian and white matches were not as important to us. They're more of the null findings, and we'll discuss that in a little bit. But as we can see here, like, let's just take a look at the first thing. So let's look at Latinx matches. For a 2-year college enrollment, you are 5 percentage points more likely to attend a 2-year college if you were a Latinx student and had a Latinx teacher in your math or STEM class, as opposed to only 1 percentage point is what was your chances beforehand of going. And if we slide all the way over, let's just take a look at major declaration. Let's see STEM major, for example. If you're a Latinx student and had a Latinx teacher in your STEM class, you are 9 percentage points more likely to go to college and declare yourself as a STEM major, not just take STEM classes, but declare yourself and try to go into that field long term, as opposed to just 1 percentage point. So a huge difference here. And then again, with the same thing with kind of the cumulative results. So we have 1 match, 2 match, 3 matches, or 4 matches. So as kind of I highlighted earlier, and very interesting to see here, there's a progression as we go up. For example, with 4 matches, if you're a Black student, you are 9 percentage points more likely to attend a 4-year college, as opposed to only 2 percentage points if you had 4 same race or ethnicity teachers. And again, the same goes for the STEM major declarations. We see this constant increase as we go along. So a quick summary of the findings, even though we kind of already just looked at it. Clearly from table 2, we could see that there was an increase in percentage points for those who attended colleges when, or 2 or 4 year universities, I should say, when in relation to having a same race or ethnicity teacher. And same thing happened here whenever we saw that the greater the number of matches you had, the more likely you were to go to college and major in math or STEM. So that was something from table 3. Now, these results are not as evident in the null findings for white and Asian students, which it's always been known that these underrepresented minorities, being Black and Latinx, do tend to underperform their white and Asian colleagues in their classes. So though we don't see the same evidence, that might be just because it's not as powerful of an association for them, because most math and STEM teachers are white. So maybe there's not as powerful of an impact, but that's something we were thinking here. Quick mention on the limitations, we only use quantitative data, so we don't actually know what's going on in the classroom. We don't know if your student actually views the teacher as a role model, which is something that much work has been done on to show that that's kind of why some students continue on in these paths. And as like the Gershenson piece came in handy here when they were just talking about how your Black teacher is going to force the Black student to work harder in order to pursue these further outcomes, and they're just going to be better for the student overall. So there's less biases in that way. So we don't actually know what's going on in the classroom. That's one big thing. And we don't know what's actually causing this for sure, but this is where a lot of qualitative research can come in to investigate this topic, which would be fascinating. And one other limitation is actually that we haven't looked at all the outcomes yet. So we were actually interested in looking and investigating the college graduation and the workforce data from these students. We just haven't had time yet, but this will be something interesting we'll look into in the future. And so just a quick, recap everything of the implications here. We know that Black and Latinx students are much less likely to see a same race or ethnic teacher in their math or STEM courses. And so seeing someone like themselves can have a very powerful impact on them to help with these disparities. And again, the key takeaway happens to be with these 2 subgroups being Black and Latinx students, that they clearly benefit as opposed to their white and Asian counterparts who, again, it's not as powerful for. And the big takeaway here for policymakers is that by implementing demographic matching to a greater degree, not just the TIA and these incentive programs, but making an active choice and putting more money into trying to recruit more of these teachers that are of the same ethnic minorities could make a huge impact, and one day maybe be able to eliminate this disproportionate underrepresentation of Latinx and Black individuals in math and STEM-based fields. So that's kind of the end goal here that we're kind of interested in. And so that is all I had for you, ladies and gentlemen. Again, thank you so much for your time, and have a wonderful rest of your day. Thank you so much.